Hi everyone, welcome back to another Build Hour. I'm Michaela on the Startup Marketing team, and I'm here today with two members of our Solution Architecture team, Emre, live in the studio, and Brian, joining virtually to help address Q&A throughout the hour.
Hi, I'm Emre. I work as a solution architect at OpenAI, supporting digital native customers on building various of AI use cases, including long-running AI agents.
So today's topic is agent memory patterns, which is a very exciting topic, and Emre and I's first ever Build Hour. So if you've been following along, we started with how to build agents from scratch using Responses API, then moved into Agent RFT, and today exploring agent memory patterns. All of the sessions are up on our YouTube channel, so definitely check them out if you want to catch up or revisit earlier builds. Though the focus on the Build Hour is to empower you with the best practices, tools, and AI expertise to scale your company using OpenAI APIs and models. So for today's Build Hour, we'll start with an introduction to context engineering, the foundation for agent memory, and then Emre will walk through several live demos covering memory patterns like reshape and fit, isolate and route, and extract and retrieve. We'll end with best practices, resources, and of course, live Q&A. On the right-hand side of the screen, you can drop questions into the Q&A box anytime during the session. Our team is monitoring both in the room and virtually to help answer throughout, and we'll save a few for the end to go through live. All right, with that, I'll hand it over to Emre to kick things off.
Thanks, Michaela. Hi, everyone. So I'll start the first part of this session with context engineering definition. So this nice definition is from Andre Karpati. I'll start by emphasizing that the context engineering is both an art and a science. So it's art because it involves judgment. So you have to decide what matters most at a given step of a reasoning or action processes. It's science because there are concrete patterns, methods, and measurable impacts to make context management more systematic and repeatable. So I'll highlight that modern LLMs don't just perform based on the model quality, but they perform based on the context you give them. In this slide, I want to talk about different disciplines that comes together to basically present the context engineering. So it is a broader discipline than any single technique like prompt engineering or retrieval. So the diagram visually represents the ecosystem of context optimization layers that together shape what the model sees and understands. So you see prompt engineering as a core principle, structured output, RAG, state and history management. Memory is also a crucial part. So using persistent or semi-persistent storage like files, databases, or memory tools to offload and retrieve key information. And all of this is contained inside the larger sphere of context engineering. So we can also connect these capabilities into different product capabilities. Here is a nice summarization slide that talks about the core principles. Like why it matters, because long-running tools, long-running and tool-heavy agents bloat tokens and degrade quality via poisoning, noise, and confusion and bursting. We have three core strategies, as we discussed in the beginning, like reshape and fit to the context window, isolate and route the right amount of context to the right agent, and extract high-quality memories to retrieve in the right time. We also have prompt and tool hygiene as a core principle. So keeping system prompts lean, clear, and well-structured. Use a small canonical set of featured examples and minimize overlapping tools and get the tool selection. And our goal and North Star is basically aiming for the smallest high signal context that maximize the likelihood of the desired outcome. And then in this slide is where our transition from why context engineering matters to how to actually do it in practice. So I'll frame this as a toolkit of techniques. So these are not mutually exclusive. So most real-world agent architectures combine multiple strategies depending on the use case and the context budget. So the first technique is reshape and fit. We can apply context trimming, compaction, and summarization. The second one is isolate and route. We can offload context and tools to specific sub-agents with a selective handoff. And the last bucket is extract and retrieve. We can talk about memory extraction, state management, and memory retrieval in that last bucket. When we talk about context engineering, it's essential to distinguish between short-term and long-term memory because they solve very different problems. I think we can group the first two buckets as short-term memory, which we also call as in-session techniques. And then the last bucket is long-term memory. We call it cross-session. So that means you can collect different information from multiple sessions, and you can retrieve back in the next session or other sessions in the future. So short-term memory is all about like making the most of the context window during an active interaction and active conversation. And then in contrast, long-term memory is about building continuity across the sessions. Cool. So we often get excited about how powerful our agents are becoming, how AI models are getting them better and better. They can handle complex tasks, route between tools. They can plan multi-step workflows. But underneath all that, there is a core bottleneck because context is finite. So every piece of information we add to the prompt, instructions, conversation history, tool outputs, competes for space in a fixed token budget. And this is why it matters slide. I want to make the problem concrete here. So I'll frame it around before and after contrast. So you see two conversations, what happens with our memory on the left and what happens with memory on the right. So on the left-hand side, the user started with the issues like Wi-Fi battery and overheating in IT troubleshooting agent. After many turns, the agent has forgotten the earlier context. It falls back to re-asking for information that the user already gave, right? But on the right-hand side, the agent remembers the original issues. Even after many turns, it can pick up the unresolved thread. It references previous actions like firmware update, background sync, which makes it feel intelligent and reliable. So this is such a stateful behavior, which is the foundation of a long-running agent. Now I'll switch gears to failure mode. So we can group these failure modes into 4 categories. The first one is context burst. So you can imagine it as a sudden token spike in one of or multiple components to do the limited external control or increased calls. Context conflict, if there's any contradictory instructions or information in your context. Context poisoning, if there's any incorrect information that enters the context and propagates over the turns. It can be via summaries or memory objects, state objects you're injecting into the context. And then finally, context noise. So you can imagine it as multiple tool definitions or like way more and many tool definitions coming into your context at the same time. This can be redundant or overly similar items, so that can make a noise in the context. Here's a nice visualization of context burst in tool-heavy workflows. So you'll see that there will be like a specific increase in one specific turn, and you'll be injecting like large amount of tool tokens here. And then the next one is context conflict. So we can easily visualize it here. So you can imagine in one of the turns, there's a specific tool call. And here in this tool call, you see that in the system instructions that never issue a refund if warranty status is not active. But in the middle of the turn, you're also saying that it's eligible for refund for VIP customers. But at the end of the turn, and your agent is responding, hey, given your urgent travel, I can issue a full refund. So this is a nice visualization or example for the specific context conflict that can be coming from one of the tool results. And then last one is context poisoning. So you can imagine it as a hallucination or something inaccurate mixed into the context in any step and propagates across different turns. So here we have a couple of possible pitfalls here. Lossy summarization edits can be causing this. If you're using like free-form notes that accumulates over time, that can be contradict. And then finally, older summaries overwrite the newer ones, and you'll be basically causing any hallucinations because of the summary logic, and you'll be injecting that hallucination into the context and propagating over time. Cool. Now I'll stop sharing my screen and switch to the demo that I prepared for you. And then I'll go over some of these challenges to show you like how it actually works in a real world scenario. Okay, let me share my screen. Cool. So here I prepared a demo app for this build hour. It is an IT troubleshooting agent for software solving issues, for issues related to both software and hardware. And this is a dual agent demo that lets you run two agents side by side. So backend logic stays inside the Next.js app, and I'll be using OpenAI Agents SDK. So we have two tools connected to that agent. One of them is get orders, and other one is get policy. So here I can start sending a message and saying hi to both of the agents, right? And then you'll see that both of the agents are responding to my message. And then here I can say, hey, my laptop fan is making weird noises while I'm playing games. Is it normal? So here you see that the configuration for both of the agents are same. They're the same model, same reasoning level, but I'm sending the same message, and there is no memory, there is no memory configuration yet. So here you also see the context usage bars at the top. So you're seeing different type of components that is already in the context now. And I can say, hey, before that, I want to see my orders. My order number is 1, 2, 3, 4, 5. So now I'm expecting the model to make a tool call and show me the orders I have. So here you see that the order status, the items I have, and it's powered by a specific tool call. So as you see over time, it will accumulating different tokens and different type of tokens here. And in the context lifecycles, I'm visualizing what is happening under the hood across multiple turns. So here you see that I have 84 tokens of system instructions. My user input is increasing slowly, but the core component here is agent output that will be generated by a model. Cool. So this is a typical real-world scenario. So now I also want to showcase like how context burst is happening. So I can still start with hi, and I can say, hey, this time I'm having an overheating issue on my laptop, and then the model is responding to my message, to my issue, basically. And then here it's telling me like specific instructions, and it's asking me some questions to better understand what's happening, right? And then I can say, hey, thanks. Before that, I want to see the refund policy of my MacBook Pro 2014. So while I'm sending this message, I also want to quickly show you the code and core concept of how it's working. So it's powered by OpenAI's Agents SDK. And here you see the agent definition. So it's a customer support assistant. I'm having specific instructions here that I'm adding. I'm using different models here. And also I can show you the system prompt really quickly. Instructions. So it's basically, I'm saying that, hey, you're a customer support assistant for devices. And then I'm using like very slight prompting and instructions for that specific agent here. So let's go back to the response. So since I asked about the specific refund policy for my MacBook Pro 2014, it's made a tool call called get refund, and it's basically returning a specific refund policy that I added before. So here you see that in between turn 2 and turn 3, there is a specific spike in the context window. So in turn 2, I had maybe around like 300, 400 tokens, but now I have more than 3,000 tokens because I am just dumping lots of information into the context. And then this is a nice example for context burst here. Instead of maybe just dumping all of this information into the context as a refund policy, I can be more careful about my tool definitions and tool outputs to basically make a decision about like what should I inject into the context. So maybe not all of these information are valuable, but as you see that I'll be injecting lots of information into the context that's visualized here in this context lifecycle tab. Cool. Now I'll stop sharing my screen and go back to the deck. So I'll continue with the next steps here. Okay. Nice. So we talked about challenges and what's going on under the hood and a specific example about context burst. So now let's talk about the solution, right? So the solution is basically managing context efficiently using different techniques such as framing, compaction, state management, memories, and make the natural step beyond prompt engineering. Again, this is also another visualization about different components in the context. So you see that across the times, it's increasing, the token counts are increasing, and these tokens can be coming from the system message, user message. Maybe you might be injecting memories, or maybe you might be injecting different type of specific tokens that can be added into your context. Here, I want to group AI agents in terms of context profiles. So we can group them into 3 categories. So first one is RAG-heavy assistance. So you can imagine reports, policy QA agents. In these type of agents, context is mostly dominated by retrieved knowledge and citations. The second one is tool-heavy workflows. So context is mostly dominated by frequent tool calls and returned payloads. And last one is conversational concierge. So you can think about planning agents, coaching agents. And in this case, context is mostly dominated by growing dialogue history. There'll be lots of tokens in conversation history, like assistant usage tokens that scales with session lengths. And then to better understand the solution and the techniques, we can go over what is fixed in our context and what is dynamic and variable. So here you see different type of components, like usually system instructions, tool definitions, and examples, unless you're doing a RAG approach, is mostly static in the context. What is dynamic is tool results, retrieved knowledge, memories, and conversation history. So these are the nice examples for dynamic and static context and tokens. So you have a control on dynamic tokens, and you can apply different techniques to control it efficiently. So I would like to start with prompting best practices to avoid context conflict here. You can also find it from our prompting guides and cookbooks. The first rule is being explicit and structured. We suggest you to use clear, direct language and specific enough to guide action. You should give room for planning and self-reflection. I think this is becoming more and more important with reasoning models like GPT-5. And you should avoid conflicts. So keep the tool set small and non-overlapping. Don't use ambiguous definitions. Even if a human can pick a tool, the model won't either. So be careful with conflicting instructions and tool definitions. So for context noise, we talked about like many tool definitions and many tools attached into the context as an example situation. Again, you should be explicit and structured in your prompts. More tools isn't always equal to better outcomes. So favor targeted tools with clear tool decision boundaries, and then return meaningful context from your tools. So in the demo, you show that specific example of context burst. So we suggest you to control basically what is the tool output, and then return high signal, semantically useful fields, and prefer human readable identifiers. Nice. So now I'll switch gears to engineering techniques. And I'll start with the first one, which is reshape and fit. So the first technique here is context trimming. So it is a pretty basic technique. It basically means that dropping older terms while keeping the last end terms. Here in the turn end, we have like limited context. It's getting noisy. There's lots of information in the context. It can be coming from a tool, user message, or different sources. And there's higher likelihood of losing track because we are getting close to context limit. But once we trim the older conversations, older messages, now we have fresh context. It has better attention, and you'll see that it will also increase the latency that you're using. So it basically keeps the last end messages and trims the previous older messages. And these are just some parameters and knobs we have control over in context trimming. The second technique is context compaction. It basically means just dropping tool calls or tool call results from the older terms while keeping the rest of the messages. So if you have a tool-heavy agent, you can consider these techniques. You'll see that your context will be mostly dominated by tool results. It will be noisy. There'll be maybe some context noise and lots of information coming from different tools. And after compaction, you'll see that there will be fresh context, better attention, and faster processing. And you will also be keeping the tool placeholders intact even after the context compaction here. And a question you might have would be like, okay, how can I decide heuristics about trimming and compaction? So here I can share a couple suggestions. So first, you can analyze your sessions. You can collect like context snapshots from production or from your users. You can collect thumbs down and dislike context to see what's going wrong there. Think about the average token size of a context. What type of task do you have in one session? Secondly, like do not trim mid-turn and break turn blocks. So a turn basically means that a user message and all the other message until the next user message, right? So if you just break or don't respect these turns, there will be higher likelihood of losing track. And then finally, don't wait to hit context window limits. So keep track of context allocation. You can set thresholds like 40 or 80%. So if you're getting closer to hitting the context window limits, these thresholds will help you to better understand basically when you should trigger some of these operations. You can control tool outputs, and you can also keep track of token saves. So these techniques are also really nice for reducing cost purposes. And you can always keep track of like how much token you're saving while you're increasing the overall capability of your agent. And then the next technique we have is context summarization. So it basically means compressing prior messages into structured summaries, and you can inject into the context history. So here in turn end, you see lots of messages, noisy context again, and you're basically keeping the last n messages and just summarizing or compressing the previous ones so that you'll have fresh context, better attention, faster processing, and at the end of the day, you'll have a golden summary. So this will be like a valuable information because you'll be basically compressing all of the valuable informations. And at the end of the day, it will have like a very dense object that you can keep track of. And that will be also useful for you to better understand what happened in the conversation. And here's a nice visualization in the context lifecycle about the summarization. So let's say you perform the summarization in a specific turn. So you'll see that you are compressing all the previous information and injecting it back into the context as a memory object. So you see there is a new component called as memory after the summarization performed. Nice. So here is a comparison of summarization versus trimming. So there are different dimensions that you can consider while you're designing a memory pattern for your agent. You can see that in trimming, you'll just keep last entrants and you'll be dropping the oldest ones. So basically, it'll be pretty straightforward operation. So it'll be very fast. There's no latency. But the trade-off is that you might be losing some information that is already there. So I think this is the main trade-off that we have. It's really best for tool-heavy ops and short workflows. And then in summarizing, you basically just keeping track of all the information, so you're not throwing away anything. This can add a little bit of latency and cost because you'll be doing another summarization call to a model, but you'll be just collecting all the information. So you can think about an agent or use case. If you have like multiple tasks in your long-running agent that are independent from each other, you can definitely consider trimming, because probably the trimmed or thrown away information is not important for the agent for the next turns. But if you're collecting useful information across multiple turns and tasks are dependent to each other, then you can definitely consider summarization here. Nice. So now I'll stop sharing my screen and go back to the demo. I'll show you a couple examples of these techniques that we already covered here. Let me quickly share my screen. Nice. So here, let's go to configurations page on the demo. So for agent B, I want to enable trimming, and I can basically set max turns as 3 to trigger the trimming operation. I want to keep recent turns as 3. So here I can start again to test my agent and saying hi. So this time I want to understand the refund policy that I want to check. Maybe I want to refund the laptop I just bought. I can say, hey, I want to see a refund policy for my MacBook about a month ago. And I want to understand like what's happening here in terms of refund. So if I'm eligible or if I'm not eligible. So the model is now making a tool call and calling the get refund tool here. As you see, it's returning that specific information. I have 30-day return window for returning that specific laptop. And I also want to check my order. So I changed my mind and I'm saying, hey, can we also check my order? My order number is 12345. And I want to see like if it's on the way, if it's coming. So you see that the model is doing another tool call as get order. And now I want to switch gears. I can say, hey, thanks, I'm having an issue with the internet connection. So until this turn, you see that I have lots of tool tokens here in context lifecycle. So it's getting accumulating over turns. And in that specific turn, now it's telling me that, hey, let's sort it out. It's asking me a couple of questions about my device. And I can say, hey, I tried to load an internet page and still see 404 error. I basically share a couple important information about the situation. And you still see that across the turns, it's accumulating lots of tokens, and even agent output is increasing. Okay, so let's say it's still happening on Safari, and then this is the last message probably that I want to share about the current situation, and I'm waiting to have more guidance and instructions here. And here you see that at the end of turn 6, the context is trimmed. If I go back to here to visualize what's happening, so when I hit the turn 6, you see that it trimmed the context. So it basically removed all these tool outputs and tool tokens. So now I have a fresh context here. And then now I can continue talking about the same specific issue, or I can continue to talk about like different different information. Nice. So let's go back. And then here, I also want to show you how summarization works. So also the compaction is also works in a similar way as trimming. So here I can set like compaction trigger S4 and keep recent turns too. So you'll see that at the end of turn 2, it'll be compacting and removing all these tool outputs, and I'll have a fresh context similar to the trimming approach. But now I want to be a little bit more advanced here. So here I want to enable summarization. I want to set the summarization trigger as 5, and I want to keep the recent 3 turns. So here I clicked save, and now I want to just see how it's summarizing all these information. So here I'm sending, hey, I'm having internet connection again. So this time I decided to share more and more information about my situation. So I can say where I bought this computer, what is the model. So I can say, hey, I have a 2014 MacBook Pro 14-inch, and I live in the US, but I bought it from Amsterdam. I received it from a battery change service and just updated the OS version last week. And they asked me to update the OS version to macOS Sequoia. So as you see, I'm sharing like many information, and these informations are really available for an IT troubleshooting agent, right? And here I can go back and say, okay, these are nice, clarify the problem, like what I need from you. And I can say, hey, I already tried hard reset after checking the FAQ docs, but it didn't work. So this is still in a form of memory because I'm sharing like which steps I tried, which worked and which didn't work. I can go back and continue talking with the agent. So now it's reasoning itself and providing me like more detailed guidance and instructions for specific to a MacBook. So I went back to my computer and I saw that the Wi-Fi icon is not active. And then I'm thinking maybe it's related to Wi-Fi, or maybe it's related to a specific software issue. So as you see across the turns, it's getting more complex. The agent needs to reason, and the agent also needs to keep track of what's in its context and make sure that it's not there is no burst, there is no conflict, there is no poisoning and other type of failure modes. It's telling me some specific steps, and I can say, hey, I tried it already, and I'm wondering if it's a specific software issue, right? And then here I'm waiting for the response from the agent. So again, I shared lots of information here, lots of valuable information. So now the agent knows my device, where I bought this device, which steps I tried, and basically what type of steps I performed before doing that. Cool. So now you see that it's responded to me like a very well-structured instructions, given what you described. Wi-Fi icon is not active, blah, blah. And then here I see that the context is summarized. And I noticed that there is an orange component we count as memory item. And the memory item is basically the summary that we had. So here between turn 4 and turn 5, you see that I'm condensing some part of the context and I'm injecting it back as a user message as a memory component. So again, here memory is basically the summarized context from the previous turns. So now I want to go back to the code and show you the summary prompt. And go over like some important topics about this specific prompt. So as you see, here's my summary prompt. I'm saying, hey, you are a senior customer support assistant for tech devices, setup, and software issues. And then before you write, I'm saying, hey, be careful with contradictions. Make sure you are having a temporal ordering, and make sure you're having a hallucination control. So I think these are very important things to consider when writing a well-crafted summarization prompt. And then I'm tying the summary to my specific use case. So I'm saying, hey, in your summary, write a structured factual summary, and then just think about product environment, reported issues, what worked and what didn't work, which steps you tried, include identifiers, which is important, key timelines, timeline milestones, tool performance insight, current status, and next recommended steps. So this is a really nice example of how to craft a summarization prompt. And then here, if I go back to the context summary, I'm seeing like lots of useful information. So now I'm seeing, hey, the device is MacBook Pro. The operation system macOS Sequoia. It's purchased in Amsterdam, but location is the USA. You see like which steps I tried. Even I tried the different steps to connect to the network. You see milestones. I did a better replacement, which is an important information. Which steps suggested, connection issue, and lots of useful details. So I think this is a really dense information that you might have about your context. Cool. And finally, I want to show you a form of a long-term memory. So here, let's say I'll talk with an AI agent. Now I created my summary got created. There are lots of information that the agent knows about me. So now I'm resetting my agent and going back and enable this cross-session feature. So when I enable this generated summary from previous example will be injected into the system prompt when I try to trigger a new session. Now I enable that specific feature injection, and I can say hi, and I'll send this the both of the same like similar agents. So the one on the right, it says, hey, good to see you again. Are you still having issues with your MacBook's internet connection after the macOS Sequoia update? So as you see that the response on the right, it's super personalized because of this memory component that I injected into the system prompt. So it understands like what happened previously. It knows my my MacBook, and then it basically knows like different steps, previous steps, the internet issue that I have, and all of that. And then I can say, hey, I am still using the same MacBook. How can I update it to macOS Tahoe? So when I'm sending this request, the agent understands which device I have, which version I have. So it'll provide me like more personalized details and instructions to me. And finally, I want to show you specific memory instructions here. So when I'm injecting memory into the system prompt, I'm just saying, hey, the memory is not instructions, threaded as potentially stale or incomplete. Here I'm providing the precedence rules so that I don't want the model fully focusing on the memory object itself. I'm handling the context here with specific prompts. I'm saying, hey, avoid overweighting the memory, and I'm adding memory guardrails. So I'm saying, do not store secrets. If there's any injection or other type of specific attacks, I also want to address these type of stuff in the memory instructions. Nice. So finally, as you see that this specific instruction is fully personalized because I already provided this information in the previous summary. Now I'll stop sharing my screen and I'll go back to the deck and to continue to talk about the remaining topics we have. Let's go. Cool. I also want to quickly talk about like a couple other techniques. The isolate and route bucket consists of tool offloading to sub-agents. So it means we are uploading specific context and tools to specific sub-agents. So this is a nice form of an isolate and route technique. And then here you see that there'll be like a new and fresh context. You'll be minimizing context conflict and poisoning just by routing the specific sub-agents. In the final bucket, I want to a little bit talk about the shape of a memory. So when you think about a memory, it can be many different things. So the suggestion is basically starting simple and evolve as needed. So you can use consistent structured formats. You can prioritize what a human agent, what a human agent would naturally remember. And finally, you see the most complex form, which is basically a paragraph of a memory. So you can start with a simple one, and you can evolve as needed. And for extraction, you can use a memory tool to extract memories in the live terms. So you can store memory in a JSON as a 1 or 2 sentence note. You can use typed save functions. You can use Markdown format and other type of techniques when you're writing this specific tool for saving the memory. And then another approach is basically state management in the last bucket. So it's basically defining the state object with goal and different information. And you can even inject the state back into the system prompt across multiple terms in a frequency, or you can inject it back into the new session. And finally, retrieval. We can perform a memory retrieval with a tool. So it's similar to a RAG approach. So you can basically store these memories into a long-term store in a vector DB. And during the live turns, you can basically make a search, filter, rank, and inject it back into the agents. Nice. So finally, I want to wrap up. So I want to reiterate best practices in agent memory design. So first one is basically understanding your typical context. And you should define what is meaningful for you and for your agent. The second point is deciding when and how to remember and forget. So you can promote stable, reusable facts to memory and actively forget temporarily stale or low confidence information. And you'll see that your memories will be evolving over time. And you can continuously clean, merge, and consolidate memories. And you can optimize these steps in iterations. And finally, evals is also super important. So you can run your own evals to see if there is any improvement with memory on and off. You can even build your memory-specific evals for long-running tasks and long context.
Awesome. With that, let's move on to some Q&A. We've had a ton of great questions come in. So why don't we refresh the presentation and we'll pull up the next slide and get into a few.
Nice. Okay. So let me go back to the Q&A session and jump into the questions we have. So let me quickly share it again. Nice. Okay. Yeah, let's start with the first questions. Yeah, so there are any libraries or packages to recommend for context engineering. So this demo is built by using OpenAI's Agents SDK package and library. It gives you a really good flexibility to implement your own sessions. And in these sessions, you can easily implement like trimming, compaction, summarization, and all of that type of techniques easily here. So I see many different libraries that are evolving really fast to basically make your life easier for context engineering. So as you see, we have too many techniques, and each technique has different parameters to tune. So I also see that there's an evolving part of all of these libraries. But I can suggest OpenAI Agents SDK as a starting point to basically start implementing specific context engineering techniques and go from there. Nice. Next one. So how do you evaluate or measure the memory feature is evolving, the memory is improving performance? So this is a really nice question. Yeah, after the session, you might think about, hey, I implemented a specific memory approach, but I don't know if it's good or not, how it's performing well. So we can maybe split this into a couple portions. So first one is basically just running your regular evals with memory and without memory. So I think this is a really nice way to start thinking about if memory feature works or not. So if you have some specific eval metrics like completeness, like upwards, downwards, or that type of metrics, you can see if there's an increase or decrease, or if there's any statistically significant uplift coming from the memory. And then maybe your evals might not be capturing well that type of memory-based boost or improvement. Then I suggest you to think about more like memory-based evals. So what I mean by memory-based evals is basically evaluating the model on long-running tasks and long context. So if you are not hitting any context thresholds, maybe your agent doesn't need any of these memory improvements at all. So again, you can start with your core evals if you have already. And then secondly, you can start creating your own memory-based evals. So you can even evaluate the quality of the summary. You can evaluate the injection time. You can evaluate the injection prompt. So there are different ways to evaluate it. But of course, in most evals, you also might need to prepare a golden data set first and think about maybe like a couple 50 examples, like golden examples of a good summary. Or you can try different heuristics that I mentioned before to basically find the right balance of trimming and compacting. So I think we can just group this into 3 different buckets. First one is running your own evals to see if there's an uplift. Second one is building memory-specific evals. And the third one is basically finding the right heuristics and parameters to apply in the context engineering techniques. Next one. So should we use hierarchical context, like entire project context for immediate task and context for immediate file edit in questions? So yes, the answer is yes, but it's mostly dependent on the use case. So we also have a concept called memory scope. So you can think about it as this memory scope as a global scope. That means if you have a customer or user of your agent, probably there's some information that you should always remember about that specific user. Maybe this user likes more friendly tones. Maybe this user lives in the US. So these are some examples for global memory. But you can also have a scope based on the specific session. So let's say I want to book a travel, and then this time I prefer window seats because I want to sleep. So this is also a nice example about the session scope and session memories. So I think this is a good practice to maybe separate these into two buckets, and you can keep track of session memories with session scope. And over time, you can graduate session memories into global memories, and you can keep track of like what is really important about the specific user. So in Travel Concierge example, if user is always saying, hey, this time I want window seat, like maybe multiple times, and you can finally graduate that memory into global memories and keep track, or keep it in agent's mind, basically, and remember that for the next bookings. Nice. Okay, so what strategies do you use to keep memory flash or prone so the agent doesn't become overloaded with stale or yeah? This is a really this is another good question. And in the real world, you see that memories are evolving really fast. So after some time, you'll see that there are some memories that you need to prune, and the agent needs to forget. So in that specific case, there are a couple techniques to apply. So first of it is basically keeping a temporal tags. Okay, I learned this memory from the user, but I learned it maybe like 2 months ago. So if you can keep track of these timestamps or temporal tags, the model will understand what is old and what is new. So if I say I like dogs, if I said I like dogs like 2 months ago, and today I say I like cats, so you'll see that the model is going to understand my favorite animal now is maybe cats, and it will override the memory with the right instructions. So this also falls into a little bit to memory consolidation. So how to prune stale memories, how to basically update and override the new ones into the existing ones. So temporal text is one technique that you can apply. The other one is you can use a way decay or basically a window function. And you can basically focus more on the recent memories, and you can basically downgrade the oldest ones. So it really depends on the nature of your use case. So if you think that what I said a year ago is not important for your agent, you can definitely prune these old ones and implement a weighted average probably for all your memories. But if you think that all of this memory is equally important for your agent, then you can consider maybe like memory consolidation and memory override with temporal text. So we can talk about two different techniques to manage the overloaded and stale memories. Nice. Okay, so how do you manage scaling agent memory systems when you have many users with individual and shared memory pools? Yeah, this is also another good example from real world. So once you see the memories are evolving over time, and you'll see that you're collecting tons of memories from your users. So there are different ways to scale it. I think the first path or first decision criteria starts with if you are basically performing a retrieval or search-based long-term memory approach, or you're just using basically summarizing the context. So if it's the second one, that means you're just storing all of this information and persist it into a disk. So you can think about some scaling methods about like data management, how to manage like a large amount of memory nodes as a text in a text format. Or you can basically think about scaling the first approach, which is basically you have to think about like how to scale a search and retrieval system. You might be storing all of this information into a vector database. And then in this vector database, you can try to scaling the storage. You can scale all these vectors, filtering, ranking system, and all of that. So I think the first bucket is mostly about this long-term memory. So we talked about like memory as a tool. So if you can think about extracting memories with a tool and retrieving back during the life turns, probably this is the situation where you're going to hit this question about scaling for many users. In this case, you can think about scaling techniques for vector databases. You can use sharding. You can optimize your embeddings model probably if you're using like customized embedding model. And you can basically optimize the retrieval process similar to a RAG approach. Again, the first one is mostly about scaling a retrieval system. The second one is mostly about basically like data storage, how to store specific data, how to manage tons of information and sentences. I think to wrap up, we can basically put it into two buckets. One of them is scaling and optimizing a retrieval system. The second one is also making it more efficient for storing and persistent in the disk. So this is also a common question that I hear from my customers. I think you can maybe follow like a pilot approach, and you can turn on this new memory techniques for a subgroup of your users, and you can think about okay how it's evolving over time. Maybe you'll see that most of the memories that your users are saying are pretty limited. So think about this travel concierge agent. So probably I'll just sharing my memories about my seat preference. Maybe if you want to book a hotel, I like maybe higher floors. Maybe I like the specific menu or breakfast. So I think this is more limited type of groups, type of memory possibilities, I can say, and that type of agent. But if you're building a life coach or life coach agent, so there are tons of memories that you need to remember about me, my life, and you'll see that these type of memories and memory pools are evolving really fast. So yeah, the third point is that try to understand the evolution of memory and possibilities of memory in your AI agent. So we have two examples here, travel concierge memories and then life coach memories. So yeah, as you see in the second one, you'll be collecting tons of information that is valuable for for my life, and then my dreams, my goals, what I was thinking a month ago or a year ago. So the second one is mostly like super advanced and complex and sophisticated memory pool that requires lots of scaling for sure. Okay, so yeah, that was the end of the question, the QA session, probably.
Yeah.
Okay.
Yeah, and then we can just switch to resources. So, all right, this has been awesome. To wrap things up, we've linked a few great resources here, including the Context Engineering Cookbook, which was referenced, and the Context Summarization Cookbook, and our Agents Python SDK. I know we've gotten a lot of questions on, is this available in GitHub? So you can explore all of these links on the right, and the full build hour repo is available on GitHub. So good news, we're likely going to squeeze one or two more of these in before the end of the year. So keep an eye out on our build hours page linked here. And a big thank you all so much for tuning in, and a big thanks to Emre, who's did an amazing job with this session.
Yeah, thanks everyone. We hope you enjoyed this build hour on agent memory patterns. I know we covered like lots of different techniques, lots of different information about memory, how to think about memory, how to design a memory. So overall, as you see, there are too many options, but the core idea is basically better understanding what your agent should remember and how it should remember and how it should forget. So you can think about these three things when you're designing your own agent memory. And this is still an evolving field, so you might see like some like new features coming about memory overall. But yeah, I just wanted to show you like different design trade-offs and guide you with the best option. So finding the right balance between these techniques are usually like related to your specific use case, and then you can keep track of all of the news and cookbooks in the resources section. So I'll be also uploading this demo page, so demo application to our build hours GitHub. And then yeah, thank you for your time and thank you for listening all of this.
Yeah, have a great rest of your day, and we'll see you next time.